All right, so let's try 38 and 5.4, which is this thing about repeated integration by parts, basically, from Calc 2. So sometimes you have an integral like this, right? Where you have an integral of x to the k e to some alpha x dx, right? Like this is the motivation. Sometimes this happens in Calc 2, right? How would you do this in Calc 2 land?
X to the x.
X to the k.
Oh, sorry.
So you'd like,
Make x your...
yeah, in Calc 2 land, right, you'd be like, okay, well, if I differentiate x a bunch of times, it'll go away, right? I know how to integrate e to the alpha x. So I do something like, okay, so I'm going to pick u as e to the, or x to the k, and dv is e to the alpha x. Right, and then v is 1 over alpha e to the alpha x. Right? Oh, I suppose I need a dx on that part. And then du is
kx to the k minus 1.
kx to the k minus 1 dx, right? And then you do this thing where you go, okay, so this is the integral of u dv, right? And so that part says that's uv, so uv is x to the k over alpha e to the alpha x minus the integral of v du. So I got a k over alpha x to the k minus 1 e to the alpha x dx, right? And then you take the k over alpha out, and you're one step closer to victory on this thing, right? Is it great? No. Is there a pattern you're going to observe after you do 3 of these? Yeah. Will you be able to figure it out eventually? Definitely. Do you want to do 100 of these? Hell no. Right?
Have you? Yeah.
Have you? I hope not. Okay, so this is the motivation. The motivation is, okay, so if we had a similar problem that was y is the integral of p of x e to the alpha x dx. Do you guys agree that this matches the case there?
Well, they said p is a power series, right?
P is a polynomial of finite degree. So I'm going to just suppose this. And p of x is, and let me get their notation exactly here. So it's p0 plus p1x plus p2x squared plus on up to plus p to the k x to the k, where pk isn't 0. Why would they bother to specify pk isn't 0?
Because then you would have the power of that sequence would be 1 less than k. And I think we need that for...
Basically, it'd be screwy to write this. Right? They just want to ensure that they're talking about a polynomial of degree k here. Specifically, in the case that motivated me, all the p's are 0 except for pk, which is 1. You guys all see that? Okay, so in the case that, like in my motivating case here, like really I'm looking at this thing and I'm thinking p of x is just x to the k. Right, like that would get my motivational case solved. It's possible that I might actually end up with something better here, right? Because if I could do this, right, like if differential equations was going to give me a nice, easy way to find y here, my life would be better off. Because then I could never do this thing again. I could just do this differential equations method, right? So they're going to coach me through that. So the first thing they say is just like part A. Think y is e to the alpha x times some function mu of x. Why would they think that?
It's good. It's kind of like a method of undetermined coefficients, sort of.
It's a little bit like method of undetermined coefficients. It's also looks and feels a little bit like variation of parameters, right? Like this is kind of a standard differential equation string. It's like, well, I suspect it's got an e in it, and then I'm just going to guess at the rest. And I'm going to start with multiplication because that's an easy spot to start with. Let's call that. Okay, so if that's true, then what's y prime? Like, I'm just hitting this with a ddx, just for kicks. Why am I hitting it with a ddx?
Because we're probably going to solve a differential equation.
Yeah, because I want to make a differential equation out of it because I'm sitting here thinking differential equations of this thing. So if I hit it with a ddx, what do you get over here? What do you need?
Alpha e to the alpha x times u of x.
Alpha e to the alpha x times mu of x plus,
Alpha u or
Plus e to the alpha x mu prime of x.
e to the alpha x times mu prime of x. Okay, and oh, what's y prime now? Y was that integral, right?
Oh,
So y prime, on the other hand, should be the derivative with respect to x of the integral of p of x e to the alpha x dx, right?
this is just the inside.
Which should just be the inside, which is p of x e to the alpha x. So equating first and last here, I think I got p of x e to the alpha x is alpha e to the alpha x mu of x plus, oops, e to the alpha x mu prime of x.
Oh, that's where they got the
And
differential.
then,
They
yeah.
divided by e to the alpha x.
and then if you divide through by e to the alpha x, right, slash all those guys off, you get this differential equation that says, right, if you're going to find y, the way you would find y is by solving this differential equation. So, if I'm going to find y, right, I'm going to look at y and I'm going to think it's e to the alpha x times mu of x, right? And that's going to be true when mu satisfies p of x is alpha mu plus mu prime. So that's the end of part A, right? Like, that's where they got a differential equation to solve. So now I have a differential equation that I feel like I can solve. How should I go about solving this differential equation?
You're going to have to do we'll find mu, so you have a homogeneous solution in particular.
Okay. So if I wanted to solve this, right? Yeah. Like, let's solve it. What's the homogeneous solution for this?
Oh, actually, yeah. Do we still talk about particular solutions for first order ones?
Sure.
Okay.
I haven't actually really used anything super special about the fact that this was second degree. Right? If I want to solve this, one way I could solve this is, I don't know, just think at it a little bit, right?
Well, we need the homogeneous formula to get mu homogeneous is
Okay, so solving the homogeneous equation would be mu prime plus alpha mu is 0, right? You guys see that? What would solve this?
e to the negative alpha x.
Okay, so I might just by inspection note that's e to the minus alpha x. You guys see that? Yeah? Okay, then what do I do with that? So that's all the homogeneous version. What would my particular solution guess look like?
we could do variation of parameters from this point, right?
Sure. Let's do variation
Is
of
that
parameters.
what we're doing when we're kind of, actually, we're finding a
Kind
particular
of.
by guessing that it's, okay.
Yeah, method of undetermined coefficients is a little bit dumber than variation of parameters because it doesn't work on all the forms. Does that make sense? Like variation of parameters only works in some really, or sorry, method of undetermined coefficients only works in really specific cases. But it works super well there. You could try variation of parameters, it would just be way messier. You guys kind of with that? All right, so how should I proceed?
We say,
I found,
well, if that's mu h. we'll
this is
say-
the homogeneous mu, right?
Say mu equals mu h times another letter.
Yeah, okay, so I need to guess something, right? So I'm gonna guess mu is v. I'm just gonna use v for variation, right? So v of x times e to the minus alpha x, right? Okay, and then what should I do?
Take one derivative.
Okay, so I should take a derivative. So mu prime should be v prime e to the minus alpha x minus
Minus alpha v e to the minus alpha x.
alpha v e to the minus alpha x. By that product rule, right? Okay, and then what should I do with that?
Plug it into
Plug it into my equation, which was this guy, right? So this thing is going to become v prime e to the minus alpha x minus alpha v e to the minus alpha x plus alpha times v e to the minus alpha x. Oh yeah, no surprise, those cancel, right? Like that was how I organized variation parameters. So those guys are going to drop off, and that's supposed to equal what?
p of x.
P of x.
So is this,
You guys with me here? Okay, so in the end, I got v prime is p of x times e to the alpha x. You guys see the circle we just drew? No? Maybe? We just drew a circle on the board in math. Didn't you see it?
so does that mean that mu is equal
So,
to alpha x?
Please note, this would mean that v is the integral of p of x e to the alpha x dx, right?
Which is y, right?
Which is why, because
Because y is p of x.
of course it is,
Um,
right? Because I suppose that was the form y took at the beginning.
Something like y is v prime.
You guys see, I just drew this whole big circle, because y is v, because,
Actually, it's
right? Because right here, when I supposed this back at the beginning, this said y and v were the same thing. We multiplied through by e to the alpha x, right? You get the v and y the same. So, wow, I just drew a giant circle, right? So, what should I be doing instead? You see, variation of parameters just drew a giant circle. Why did variation of parameters just draw a giant circle? Because I kind of made it do that. My guess was sort of motivated by the idea of variation of parameters, right? You guys remember that? Back in the beginning, I was like, yeah, and you would maybe make a reasonable guess like this because of variation of parameters. Right? And then when we did variation of parameters, lo and behold, we found our reasonable guess. So what should I do instead? So here's where I'm sitting back before I tried this nonsense. I had done part A, which was figure out that if y is e to the alpha x times mu of x, then mu satisfies this differential equation, right? And the thing they actually asked me to do in part B was show that this thing here, which is A, has a particular solution of the form O, and then they gave me they said, dude, it's a polynomial. Why would I expect that a particular solution of this thing would look like a polynomial?
Because trying to solve a polynomial.
Yeah, because you're trying to solve a differential equation equals to a polynomial, right? So it seems like the dumbest guess I would make, motivated by method of undetermined coefficients, would be just guess a polynomial. You guys see that? If we had two techniques to choose from, we picked the wrong one at first. Let's pick the right one now. So if I pick mu p, what degree would I expect the polynomial that I'm guessing for mu p to be?
The same as p.
It should be the same degree as p. So I'm going to guess a0 plus a1x plus up to akx to the k. You guys with me on that?
So now we're doing method of undetermined coefficients
Mhm.
in first order land, right?
Yeah. Yeah, basically I'm running an intelligent guess. You guys cool with that? Variation of parameters would have been probably a better idea. But I had already kind of used that trick up. Right? So once I've used that trick up, the only other trick I have for this is method of undetermined coefficients. So I'm going to try this. So I would motivate this guess. How would I check? Like, how would you get the coefficients here?
Oh, take derivative and plug it in and equate the.
Okay, so they didn't tell me this, right? This, all they really wanted was for you to notice that method of undetermined coefficients would do this. So once I've thought that, let me go the extra step and actually differentiate. So mu p prime should be what?
a1 plus a2x plus.
A1 plus
2a2x?
Oh,
2a2x plus 3a3x squared plus, right, and so on. And at the end here, I'm going to get k a to k x to the k minus 1, right? You guys see that? Okay, and then I'm supposed to shove these into the equation A, right? You guys see that? So let me write that out a little bit carefully. So mu p prime was a1 plus 2a2x plus 3a3x squared, and on until I get to k a k x to the k minus 1. Right? That's mu prime. What's alpha mu prime? Alpha mu p.
Alpha a1.
So alpha a naught plus alpha a1x plus
alpha a2x squared.
alpha a2x squared plus, and so on.
Alpha a.
And then there's alpha ak minus 1 with x to the k minus 1. You guys with me on that? And then what's the last term? Alpha ak x to the k, right?
We're just adding series?
Oh, never mind.
Yeah, these aren't series, right? They're finite degree. They stop, right? These are two polynomials. But yeah, I really just want to add these together, right? So if I add these together, I should get p of x over here. You guys see that? And then on that side, I got a1 plus alpha a0. That's your coefficient, right?
For the 0th degree.
For the 0 degree term. And then you got plus, and then there's 2a2 plus alpha a1 on an x. And then kind of la-di-da, right? And then at the very end, you got plus alpha AK x to the k.
That one,
What about the other alpha?
Oh, don't worry, there's a whole bunch of them.
I mean why is there only one in the
This
final
guy?
term?
Oh, why is there only one here?
Yeah.
When I differentiated, right, there's no x to the k's up here. You see that?
Yeah.
And
I
that's,
thought you just stopped early.
no. And that staggered offset's what's gonna let you solve this. Because this thing's supposed to be p, right? And just writing underneath this, p was supposed to be p0 plus p1x, and then some more stuff, and then pk x to the k. Right? So you can equate these coefficients. Right? You can be like, okay, so p0 has to be this stuff. p1 has to be that stuff. pk has to be this thing. That's going to let you solve for the AKs, for all the A's. You can see this kind of giant mess that you've bought. In the nice convenient case, right, where pk is 1 and everything else is 0,
you just need alpha.
right, then all of these guys are 0, except for this one. And you can just kind of stagger all the way through this. It's not too bad. You guys cool with that? Okay, and then part C is conclude that this, oh yeah, so this was supposed to be y, right? And then I found a particular solution. Okay, so I think equating these things together gets you part C pretty easily. You guys cool with this?
Would this in the end give us like a way that we can actually use in real life on something, or is it just like, I get like it's a cool different way, but is this something that we can memorize in the end, like parts is?
Yeah, you could, so this would be easier in the case where pk is 1, right? And you could go through this and do these equations and solve them backwards. Most of these are 0 equals something, right? So you're going to get all of these in terms of that one. Shouldn't be too bad. I would say probably, like personally, I'm much more comfortable with parts than I am with this business. It's cool that there's another way to do this, but for me, parts is probably easier. This, however, is way easier to teach a computer to do. Right? Teaching a computer to do parts might be a little more complicated, but this I can have a computer do really easily. You guys see that? This will make a pretty easy algorithm to plug in.
Is that how they do it in calculators?
Keep going R to K.
'Cause it, like,
It depends on the calculator.
Because we learned that when we learned Taylor series, that's how they do, calculators do.
Yeah,
Sines
that's
and
kind of
cosines.
fundamentally how calculators do everything, is with Taylor series approximation. I'm not sure whether they use this method or whether they've been programmed to do a method for integration by parts. My best guess is that it depends on the calculator, actually. Probably the TI-89 does some nasty numerics, and like Wolfram Alpha probably does something more slicker, more like this. Cool.